All right, we're going to take a look now at the binomial distribution. A binomial distribution is a special type of discrete random distribution or discrete random variable that has three requirements that must be met in order for the discrete probability distribution or discrete random variable that you're looking at to be a binomial. So the three requirements for a binomial are as follows. The first requirement is that you must have two possible outcomes. We call these possible outcomes in a binomial the success and the failure. So if I'm flipping a coin and I'm trying to get heads, if I flip a coin and I get a heads, that's a success. If I flip a coin and I get a tails, that's a failure. I could also do this with dice. If I'm rolling a dice and I'm trying to get a 6, rolling the dice and getting a 6 is a success. Rolling any other number would be considered a failure. The second requirement is that I have a fixed number of trials. So what this means is before I start my experiment, I know how many times I'm going to repeat it before I begin. So before I start flipping the coin to see how many heads I get, I've decided I'm going to do this 10 times, or I'm going to do this 100 times, or 1,000 times, or 50 times, whatever it is. What I can't say is I'm going to keep going until I get 10 heads. That's not okay. And the last requirement is that my trials are independent. So that means that the probability of a success is the same for every trial. It doesn't change from one trial to the next. So these are the three requirements that we have to meet every single time for it to be a binomial. If one of these three requirements is not met, then it is not a binomial. It is just a discrete probability distribution. So we're going to take a look at a few examples. The first example says an engineer is designing a new light bulb designed to last for 1,000 hours. It is known that the probability that the light bulb will last the full 1,000 hours is 0.95. The engineer grabs 10 light bulbs to test to ensure quality before sending them out to be used in a new building project. So if I start looking at my requirements, the first requirement is that I have two outcomes. And I do. Either the light bulb lasts the stated 10,000 or 1,000 hours, or it doesn't, and the light burns out early. The second one is a fixed number of trials. And I have that too, right here, 10 light bulbs. And this one, independent. Are the light bulbs independent from one another? Now, what would have really helped in this one to make this easy to determine is if it had said that the engineer grabbed 10 random light bulbs. The word random is like a flashing sign that says, these are independent. But we don't have that. So what we have to ask ourselves is, would one light bulb, oh, I'm so sorry that I turned that. I thought I had it locked. What we have to ask ourselves is, would one light bulb burning out prematurely affect the next light bulb burning out prematurely? And maybe if we knew that they were coming off of like the same machine, but we don't know that either. So we're going to assume yes, because we don't have any clear information to say that they aren't independent. But again, including the word random in here would have been a really surefire way for us to know that they were independent. But with all three of these things met, we can say that yes, this is a binomial. Yay! So let's look at the next one. A trainer is teaching a dolphin to do tricks. The probability that the dolphin successfully performs the trick is 35%. The trainer continues having the dolphin attempt the trick until they successfully complete the trick 20 times. So, do we have two outcomes? We do. Either the dolphin does the trick or they don't do the trick. Second condition, do we have a fixed number of outcomes? Or sorry, fixed number of trials? No, we don't. All we know is that the dolphin is going to keep going until they do the trick 20 times. But how many repetitions is that going to take? How many trials of doing the trick is that going to take? 20, 25, 30, 40, 50? We don't know. So because requirement number 2 is not met, this is not a binomial. Sad. It could be a discrete probability distribution, but it's not a binomial. Looking at the next one. 70% of people pass the state driver's written exam on the first try. A group of 50 individuals are randomly selected, and the number of correct answers on their exam is recorded. So do we have two possible outcomes? Right away, no. We are recording the number of correct answers, and depending on where we are, that could be anything from 0 to 10, 0 to 20, 0 to 30. I don't know how many questions are on the state driver's test anymore. I think when I took it, there were 10, maybe 20. I don't remember, to be totally honest with you. And I don't know if every state has the same number of questions. So there could be a lot of different outcomes here. If this question had said that the 50 individuals were randomly selected and the number of people that passed was recorded, then this would have been met. But that's not what they were recording. So right away, it is not a binomial. We do have a fixed number of trials, and we do have randomly selected people, so they are independent. But because we don't have the two outcomes, it's not a binomial, even though the other two things are met. And the last one. A college has a student advisory board made up of 10 staff members and 6 students. The committee wishes to choose a chairperson and a recorder for the next academic year. What is the probability that both positions are filled by students? So for this one, I'm going to reread it again, and I want you to take a minute and see if you can come up with the answer. Actually, I'm not going to read it again, but I'm just going to give you a minute to look through this one before I start going through the answer. So you could pause the video if you want more time. All right, so we're not going to answer the probability part of this. We just want to know, is it a binomial? So first thing, do we have two outcomes? Yes, there are two positions, and we could fill them with either a staff member or a student. So those are the two outcomes, staff or student. And the one we're interested in is student. That's our success. A staff member is a failure. Second thing, do we have a fixed number of trials? Yes, we have 2 trials. There are 2 positions, so we're only going to be picking 2 people. And the last one, do we have independent trials? Hopefully, this is where you said no. Because the same person cannot do both roles, once one person is picked, the overall total changes. So the probability of getting a student for the second trial is lower or higher, is changed. Let's say changed, because I haven't actually done the calculations because I don't need to. So this is not a binomial. And we can shorthand binomial to binome, which we will be doing a lot. So there were some examples looking at whether or not scenarios were binomial distributions based on the 3 requirements for a binomial.